mathematical model of an accelerometer. Accelerometer means already we have seen pendulum example. In that pendulum, it swings between left and right. When it is vertical, while swinging between left and right, when it is vertical, the velocity will be maximum. If it goes to the rightmost, velocity is 0. If it comes to leftmost, the velocity is 0. But the acceleration is maximum because the velocity is changing its direction. The displacement is changing its direction. That's why acceleration is maximum. Acceleration is, because of that, it is coming back. Otherwise, it will be there only. Because acceleration is not 0, that's why it's there. So that way we can understand the acceleration. Rate of change of velocity, that is acceleration. This is acceleration meter, accelerometer, to measure the acceleration. It's nothing but a small mass is placed inside, that's all. A small mass is placed inside a box. This is a box. This is a box in which a small mass is placed inside. That's all accelerometer. It has one spring. It has one spring and a dashpot. The mass has the property, or if the property of the spring, the property of mass has 0 spring constant, 0 B means we can attach additional. Like that you can imagine. So it has one mass, one spring and a dashpot it has. That's all. That's all about accelerometer. I want to measure the acceleration of your body. With that body, it is attached. That's why this line, these lines are, it is attached to a mass of which we have to find the acceleration. That's all. Here, it is attached to a mass whose acceleration has to be found. Its displacement is x. It is attached to this a car, let us assume. The displacement of that car is x. Now we have to find the acceleration of that car. The acceleration of the car can be found from this y. This y is the displacement of this mass. Because this mass is loosely fitted. One side is spring, another side dashpot. It is loosely fitted. It is not rigidly fitted to the mass box. It is loosely fitted to the box. That's why it can move. It can move. The displacement is y. Now we will write the mathematical model. From that, we can understand what is the acceleration. What are the reaction forces here? Reaction forces are Fm, Fb, and Fk. There is no applied force, that's why 0. No applied force. F of t, applied force equal to 0. That's why the right hand side is 0. Left hand side, M. The reaction force because of mass. The reaction force because of dashpot. The reaction force because of spring. What is the reaction force because of mass? M multiplied by d square, the displacement, by dt square. What is the displacement of this mass M? It is loosely fitted. If you travel in bus, if bus starts, you are standing on the bus, not sitting. Which side you are moving? Opposite side you will move in the opposite. Bus is moving to the left means you will move in the right. That's why this y direction is mentioned in the opposite direction. So net result, both are in the opposite direction. Same direction means we subtracted. Same direction means subtracted, but it is in the opposite direction. That's why it should be, what is the net displacement of this M? X minus y or x plus y? For spring and dashpot, we have seen that if the same direction, the deflection is x1 minus x2. We have seen, for dashpot also, the displacement is x1 minus x2. But here we wrote y1 minus y minus x. Why? You see that the box is moving this direction. This mass, this m also move in this direction. How much? X direction. This is attached to that mass. At the same time, this mass moves to the right, as we mentioned, it moves to the right by a displacement of y. Now, what is the net displacement of the mass? X is moved this much. This end to this end, it is moved. But because of y, it comes little bit less. What is the total displacement from this one to this one only? Can you understand this point? Not like spring. If it is spring, means both are moving in the same direction. Means this is you notice that here the spring is moved to this point. Now x1, x2 is come closer. That's why the net displacement is x1 minus x2. Here the mass is moved from this point to this point. The entire box is moved. We should not say mass. The entire box is moved from this point to this point, say x. In that, the mass is little bit came this side because of acceleration. That is y. Therefore, y minus x. X minus y or y minus x? We are considering y as positive. From the diagram, we can understand that y is positive. That's why y minus x. So y minus x. M d square y minus x by dt square plus b dy by dt. As far as spring is concerned, one end is fixed, the other end is displacement of the mass by y. Therefore, for the dash part, the displacement is only y. Therefore, b dy by dt. Only y. No x displacement for the dash part. How the dash part moves, how much? Suppose the mass is not moving. What is the displacement the dash part? 0. But it moves a displacement of y. That's why b dy by dt. The spring displacement is only ky. As far as mass is concerned, the mass in the space, the free body, how much it moves is important to find the acceleration. That's why it is y minus x. Not for spring and dash part. That's all. Now you can write this x is negative. That's why you can bring this x to the other side. Therefore, m d square y by dt square plus b dy by dt plus ky equal to m d square x by dt square. But we know that we have to find the acceleration of the car in which the box is attached. That is, in the car displacement is x. We are going to find the acceleration of a car. Its displacement is x. So what is the acceleration of the car? D square x by dt square. Therefore, we are interested in m, not m. We are interested in d square x by dt square. We have to find the acceleration because it is an accelerometer. We have to measure the acceleration. So ma, we can simply put ma. Here, m d square y by dt square b dy by dt plus ky equal to m d square x by dt square. For constant acceleration, the change in acceleration, second derivative of acceleration is 0. The first derivative of acceleration is constant, 0. In that case, we can assume that d square y by dt square and dy by dt are 0. If you assume like that, only ky is there. Therefore, ma equal to ky or a equal to k by m multiplied by y. K by m multiplied y. Therefore, constant acceleration is equal to k by m multiplied by y. If you know y, you can find the acceleration. Constant acceleration. What is constant acceleration? If acceleration is constant, there is no change in velocity. It remains constant. acceleration is constant means d square y by dt is 0. Why d square y by dt square? Y is a function of acceleration. There is no change in acceleration. That's why d square y by dt square is 0. Similarly, du by dt, that is also a function of y. Y is function of acceleration. There is no change in acceleration. That's why du by dt also 0. So for a constant acceleration, the equation can be reduced to ky equal to m d square x by dt square. But d square x by dt square is acceleration. We can replace d square x by dt square as acceleration. Therefore, ky equal to ma or a equal to k by my. That's all. This is for constant acceleration. For the acceleration is not constant means, then it is called dynamic equation. Then it is called dynamic equation. In that case, what happens to the transfer function that we will see now? M s square y of s. I am taking Laplace transform. B y of s plus k y of s equal to m a of s. A of s. Acceleration. D square x by dt square can be assumed as acceleration. A of s. What is output? Acceleration is the output. What is the input? Input is displacement. Y. Therefore, we can find. Sorry, I said in the other way. Y is the output. Acceleration is the input. For accelerometer, what is the input? Acceleration is the input. What it gives, the measurement of acceleration in terms of y it is giving. For that, the scale must be in acceleration scale. The scale must be in acceleration scale. In a voltmeter, inside the voltmeter, it deflects. Deflection type voltmeter you might have seen. Actually, what it gives, a force is developed, the needle is deflecting. But what is in the scale? It is in voltage. It measures like that. The scale is in acceleration. Therefore, y is in acceleration. Therefore, y is the output. Y is the output. Acceleration is the input. Therefore, the transfer function is y of s upon a of s equal to m upon m s square plus b plus k. That's all. This is a dynamic equation. This is dynamic equation. This is dynamic equation. Here, acceleration is not constant. Acceleration is not constant. The acceleration is varying. Then the mathematical model is y of s upon a of s equal to m upon m s square plus bs plus k. Bs plus k. This is second order equation. What is the form? Pole zero form. Pole zero form. Instead of k, if you divide the equation numerator denominator by k, it is time constant form. Here, if m equal to 1, then it is pole zero form. For that, what we have to do? We have to divide by m by m, s square plus b by m, s plus k by m. This is in pole zero form. ms square plus bs plus k, neither in the pole zero form nor in the time constant form. It is in, now if you write in terms of s square, then it is in pole zero form.